This is material in motion. Material design is alive. And it lives in a world a lot like ours. A world that's responsive, natural, aware, and intentional. Material design uses responsive animation to create energy. When you take an action, feedback is immediate, and it never keeps you waiting. Motion adapts to the distance an element needs to travel, focusing on how fast something needs to move rather than how long it should take to get there. Motion should feel natural, moving the way things do in the real world. Nothing should instantly start or stop. Elements in motion have momentum and take time to speed up and slow down. They respond to forces like gravity, moving in curved paths instead of in straight lines. Material is also aware of the world around it. The way something enters the screen can affect the movement of everything else. Elements can push other elements out of the way or attract them. Above all, material isn't random. There's a purpose behind every animation. Motion guides you. It keeps you focused on what's important and makes sure you don't get lost. It also hints at how something might react, even before it's triggered. Whether your brand is fun and playful, or serious and straightforward, using the motion principles from material design can help you produce a quick, clear, and cohesive experience. Get to know how things move at design.google.com. Hello, I'm John Schlemmer. I'm the motion lead on the material design team at Google. I authored the new motion guidelines you'll see at the material spec at design.google.com. And before that, I led the motion efforts for apps like Inbox and Calendar and Gmail. So today I'm here to talk to you about motion design. Motion is becoming more and more prominent in apps today. And it's really one of the key giveaways of what makes a high-quality app. It's also one of the main components of what makes material design material. We touched on motion design a little bit in our guidelines when we introduced material a little over 2 years ago now. And it's been really exciting to see how designers and engineers have taken this to heart. Now there are over 1 million material design apps in the Play Store. With these new motion guidelines that were introduced a few months ago now, we've hopefully provide solutions for some of the challenges you may have faced when it comes to creating a transition for your app. Advanced animation in UI is still generally a pretty new thing. And we wanted to capture just what works and what doesn't when it comes to UX motion. It's really hard to describe or pinpoint what exactly doesn't feel right when a transition isn't working the way you thought it would. And what's worse, motion can be abused, just like Photoshop filters. It's really easy to go overboard and spend time implementing the wrong thing. And that's what these new motion guidelines will help you cover. We wanted to find a way to talk about how material moves, while at the same time keeping in mind just general UX practices when it comes to motion. These guidelines can help get your brand of motion to feel right, to feel really smooth. It has suggested easing curves for different kinds of movement. Durations is one of the really common asks I get. How to choreograph between views, and more. Now, a common misconception about motion is that it's just about polish. And it's not really fair to call all motion design just polish. There's so much more to it than that. And it's really one of the key components of making a great app. It's so much more than just polish. First, it can guide users to the next view. It can convey hierarchy and spatial relationships between objects both on and off the screen. It can actually help foreshadow what a particular gesture might trigger before you trigger it. It can help distract you, in a good way, from what's going on behind the scenes, like fetching content or loading the next view. And yes, it can add polish and delight to the experience, but that's really just one of the icing on the cake here. So let's take a look at this Google Calendar animation for opening and closing an event. Those of you that use Calendar should find this pretty familiar, just opening and closing an event. A lot of you probably don't really notice it anymore either. It just happens all the time. But there are a lot of really subtle things happening here to help you understand hierarchy and order, and to make sure you don't get lost when you're using it. What if it didn't have an animation at all? Without an animation, it's pretty boring and it's kind of hard to tell what was triggered. Loading also stands out a lot more because there's nothing really there to mask it. It just instantly needs to load the next screen. So this is a pretty extreme comparison, right? There's no transition here. So let's look at one of the simpler solutions that a lot of people start with. This is a default transition. It's not really taking into account the principles in the material design system, but it does have motion. Sure, it feels a little better, but it's still not really communicating anything. It just kind of slides in from the bottom. There's no relationship between the views, and there's no shared elements, and there's not really any choreography going on. There were a lot of subtleties and animation techniques used to get this calendar transition to just feel as good as it does now. And today I'd like to go over some of these motion principles. I'll loop back to this transition towards the end just to show exactly where these principles come into play once you know what we're talking about. So let's dive into the guidelines. When writing these guidelines, we really wanted to dig deep and find out why material moves the way it does. As you saw in the video in the beginning, material in motion is responsive, it's natural, it's aware, and it's intentional. And all of these are definitely loaded words. There's a lot of meaning behind each one of them. And they're all equally important too. First, material is responsive. This can mean a lot of things, especially in the world of responsive design with different screen sizes and layouts. But when it comes to motion, this means it immediately and quickly responds to your touch. In material, this response is shown with an ink ripple in the exact location that you tapped it, and a change in elevation when you tap a button. The ink ripple forms from that precise location, and the element shadow signifies that it's actually rising to your touch. It's a form of response. It also means that new surfaces can quickly be created from that precise location as well. Like when you tap an icon that creates a menu. And most importantly, it never keeps you waiting. People use our apps to get things done. The example on the right is actually something you want to avoid. If it takes too long, it'll get really, really old. To give you an idea, a typical transition duration that we use on mobile devices is about 300 milliseconds. That's really fast. That's a fraction of a second. But it's also not a duration that should be used for absolutely everything. It totally depends on how far something needs to travel or how much changes. Tablet screens, for example, have a slightly longer duration, about 450 milliseconds. This has to make up for the overall greater distance that things need to travel. Smaller screens, like on a watch, for example, have to move very short distances. It's not very far. These are often in the range of 150 to 200 milliseconds. Now on web, durations and animations in general are treated a little differently. There's a general perception on web for things to just be lightning fast. It's because when you navigate websites, there's usually no transition that takes you from one page to the next. Most websites aren't app-like experiences. So when you do have an app-like experience, you still want it to make it feel like it's at home on the web. Inbox on web, for example, uses 150 millisecond duration for its opening and closing transition. That means the web durations are twice as fast as mobile to make it feel like it's at home on the web. Also, sometimes animations need to be changed a little bit to account for these faster transitions over a larger screen. implying that an object makes a big move or expands into a larger card is different than actually physically drawing each frame of that animation. There's a little magic in motion that can imply that something is moving the way it does, and your imagination kind of fills in the in-between frames. Another thing to keep in mind is staggering content into view. Staggering list or grid items into views is pretty common practice, and it can look really good too. But each item should have a really, really short delay between entrances. You definitely should not wait for each item to finish before introducing the next one. Otherwise, especially for much larger lists, you're going to be waiting a while for that last list item to pop in. We found it's best to begin each item's staggered entrance no more than 25 milliseconds apart. It's really short. I'll get more into staggering orders and choreography a little later. So let's look at the next principle. Material is natural. The movement of material is actually inspired by forces found in our world, so physics like gravity, momentum, friction, and so on. Momentum is a really big one. Nothing in our world can instantly start or stop. It all depends on weight and surface friction. So it only makes sense for on-screen material to follow these same rules. This is where our fine-tuned easing curves really come in handy. Easing is used to add acceleration and deceleration to any type of movement on the screen. What's more, our easing curves are asymmetrical. This means that each end of the curve is slightly different from each other. Let's see how this affects some of the curves that we cover in our guidelines. The material standard curve is used for objects moving from one on-screen location to another on-screen location, and also transforming from one size to a new size. Easing is at both ends of the curve, but it accelerates just a little bit faster than it slows down. This gives the feeling that it's really energetic. It's really excited to get to that next spot. It leaps into motion, but it takes some time to slow down. The deceleration curve is used for objects entering the screen from an off-screen location. The acceleration is instant, because this is the part that actually happens off the screen. You don't actually see it. And the gradual deceleration matches that of the standard curve we just saw. This gives the illusion that it's zooming in at full speed from somewhere off in the distance, and we don't really care where it came from. The acceleration curve is used for objects exiting the screen. So the acceleration is gradual, just like the standard curve, but this time the deceleration is instant, since this is the part that happens off screen now. This gives the illusion that it's zooming out of the screen at full speed, and we don't really care where it ends up. Another concept we're introducing is what we call arc motion. Forces like gravity can actually affect how objects move up or down. This results in objects moving at a slightly curved path instead of a straight line. Doing this makes your movement feel much more natural and less robotic. This concept is actually also represented by transforming surfaces. So by slightly offsetting the width and the height transformation, you get this kind of same curved expansion path. And when objects inside that surface move along the same path, it results in a really nicely choreographed transition. And I'll get more into that a little later. Next, material is aware. It's aware of objects around it, behind it, in front of it, and even within it. This allows for really nicely choreographed motion that involve many different UI elements. As elements transition into view, they take into account the relationships between the other objects around it. This kind of connected movement gives a really nice story about how objects are related to each other, and maybe how the app is structured. surfaces can also push other surfaces out of the way. So if you're familiar with Material's elevation story, it describes how each object is set at a specific elevation level. So it only makes sense that if two cards are on that same elevation plane, and one needs to move or expand, the other needs to get pushed out of the way to make room for it. Either that, or it would actually need to rise above that other card before expanding. It knows it needs to make room to allow for that expansion one way or another. Another concept of awareness is a form of magnetism. This can be a powerful mechanism in interaction design, and it can really help define relationships and signify whether or not objects can interact with other objects. In this example, the circle is able to interact with the other circles around it, and as it approaches each circle, they can attach. When it moves away, it detaches. It makes it feel like the UI is actually doing its best to help you understand what will happen. So let's get into intention. Everything Material does is intentional. Every movement has a purpose. And its purpose is to guide you. It's to make sure that you don't get lost when you're using an app. The best way to do this that we've found is to have a common shared element between views. If you're animating a transition from point A to point B, there's more often than not an element that's present in both of those views. So in this case, we have the collapse card with the avatar in the middle, and the expanded card. All the other content changes, but the avatar is what remains consistent. So when we make this transition, we keep this avatar visible at all times. The avatar acts as a nice focal point that guides you right into the next view, right where your attention should end up. When we pair this with the asymmetrical width and height transformation that I talked about earlier, we get this really nice curved path of expansion. As a word of caution, though, it's really easy to go overboard. What if you have a lot of elements present in both views? If you have too many, your focus gets divided in a bunch of different directions, and it's really hard to follow where your attention should end up. It's okay not to keep every element consistent, and the one on the left is a good way to do this. So we touched on staggering a little earlier. We talked about how to quickly stagger them, but it's also just important to stagger them in the right order. The idea is to guide your attention in one fluid direction. So a single column list stagger is pretty straightforward. Top to bottom usually makes the most sense here. Changing this up feels unnatural and doesn't really help your hierarchy story either. Your attention is zigzagged as it appears. Having everything appear at the same time isn't really much better either. Where should your attention actually start if the whole screen is coming in at the same time? Staggering grid views is a little more complicated, and it might not be what you'd expect at first. If you have a grid view with multiple columns and rows, you actually want to treat the stagger of the grid as a whole and not row by row. If you stagger row by row, you get the zigzag of attention as items come in. Plus, it actually takes longer if you have a big grid to stagger. If you stagger from the top left to the bottom right, you get this really nice constant sense of direction as the grid comes in. Another material intention is to let you know what happens before it's going to happen. This comes in handy for gestures. So, for example, if you're using an app where a common gesture is to swipe something off the screen, what happens when you run into an item that you can't actually swipe if that swipe is disabled? How do you communicate that? you actually want to add resistance to that item to signify that it's not available here. So resistance has to do with how much an object moves in relation to how far you're dragging. That way the user immediately knows what they're trying to do isn't available here. The items that can be swiped have no resistance, and it's much easier to move around. It's like it invites you to swipe it off the screen. So those are the 4 principles of material motion: responsive, natural, aware, and intentional. By following these guidelines, you're left with a few key characteristics in your transitions. And this is a great way to judge whether or not you did the right thing during your animations. The transitions are quick. Things happen fast, so the user never has to wait. The animation on the left uses our suggested durations, about 300 milliseconds, while the one on the right doesn't. This is about 600 milliseconds. It's still only a third of a second longer, but you can really see how big of a difference this makes. Next, the transitions are clear. This plays on the guided focus and natural behavior of material. The example on the left, you can very easily follow that transition of the expansion. You get that card into the next view, and your focus is immediately always on the card. Now, the one on the right takes your attention and scatters it in a bunch of different places. Your focus is shifted everywhere, and it's really hard to tell where your attention should end up. Providing a clear sense of direction and focus goes a really long way in making your transition readable and help users understand where they're ending up. So lastly, the transitions are cohesive. You'll see 3 apps here, very different apps, but they're all following the material motion guidelines. Motion can really help unify experiences within your app or family of apps to make them feel related. So let's go back to that calendar transition from the beginning. Now that we know what we're looking for, we can kind of point out what actually makes this transition feel good when it's compared to no animation or a simpler one. First, it's responsive. We have that ink splash signifying that we tapped it, and we have that change in elevation signified by the shadow behind it. Next, it's natural. We have really nice easing curves and an arc in that expansion as it expands into the next view. Third, it's aware. So it knows it needs to lift above that other card to make room for its expansion. That's when it elevates. But it also knows that there is an app bar in the way at that same elevation it just rose to. So if you'll see, when it expands, it pushes that app bar out of the way because it's at the same elevation. And when it collapses, it brings it back down. Last, it's intentional. We use the shared element, which is the image in this case, to guide you to the top of the next view, exactly where you should be looking once you open it. It completes the story of hierarchy, and the other objects around it are choreographed in a way that follows this element too. So that's how these principles built our transitioning calendar. And I'm sure if you look at a lot of the other apps of Google, you'll find some of these similar principles in there. But let's not forget about the polished details I talked about earlier. Add in some animation where the user might enjoy it or not expect it. A common place is icon animations, so when you tap a button, changing an icon. You'll find this in Inbox. Reaching Inbox 0 is another pretty big achievement, so let's celebrate it, right? This is actually how we want our users to use the app, so let's reward them for using it the way we want them to. Or maybe you want to call out a new feature in an app, like in this example, adding pit stops and maps. You can show all the different things you can do with it during the animation without having to talk about it. Air states are another fun place to do this. You never want to experience an air, but really when you see something like this, you feel a lot better about it. So with all that said, I encourage you to take a look at the new motion guidelines at design.google.com. These are found in the Material Design Guidelines. It covers everything I talked about today and a lot more. And I'm really, really excited to see how you all end up using it. Thank you so much.